Hi, my name is Elsie, and welcome back to my series on learning objectives for data visualizations. In this video, we're going to cover how to create assessments, mostly in the form of multiple choice questions. In our previous two videos in this series, I talked about how to create and use learning objectives for design, but now we're going to take it a step further and turn those learning objectives into assessments. Let's get started. We're going to focus on this last part of the design process, and we're going to assume that you've already created one or more datavis designs. So you've created learning objectives to define project goals, you've created various designs and iterated on them, and now you want to evaluate one or more designs to see if they are successful in achieving your goals. There could be various ways to measure an outcome. One easy way to measure would be to keep track of the number of clicks, or number of shares, or length of reading time. Unfortunately, this is not actually measuring whether your goal is achieved unless your goal is to maximize clicks. It may be measuring a proxy for engagement or for how much people like it, but if your goal is to get people to remember a specific fact from your visualization, then these metrics cannot tell you whether or not it does that. But other assessments like multiple choice or open-ended questions, interviews, focus groups, or surveys can all be designed to more specifically evaluate your goal. The feedback from assessments can be used to inform what part of the visualization is or isn't working. A designer might get a small group of test users to actually answer these multiple choice questions and then aggregate scores across the group to see the average effects for each design. A learning objective is the outcome of what the viewer should be able to know or do after seeing the visualization. In this way, the designer becomes a teacher who is trying to teach the student, the viewer. For example, the viewer will compare the carbon footprint of beef and chicken. Now, the designer, as a teacher, could create a test for their viewer to see if the goal is achieved. And luckily for us, there are a lot of resources available for educators to help us figure out how to do this for datavis design. Basically, a multiple choice question has two parts: a stem that identifies the question and a set of alternatives, A, B, and C, etc. The alternatives obviously have the correct answer to the question, and then there's also a number of distractors, usually 2 or 3, which are plausible but also incorrect. I'll be going through some things to keep in mind when designing multiple choice questions, and I'll be illustrating how those things would look in this example question. For the stem, you should express the full problem and put all relevant material in the stem. Eliminate excessive wording and irrelevant information from the stem. Avoid giving verbal association clues from the stem. If the correct answer uses words that are very similar to words found in the stem, students are more likely to pick it as the correct answer. You should use familiar language. Avoid using unfamiliar expressions or esoteric terms. Check the alignment between the question and the goal. The criteria could be: if the viewer answers this question correctly, you have more confidence that they achieved the learning goal. Limit the number of alternatives. Create 2 or 3 distractors for a total of 3 or 4 options. Make sure there is only one correct answer. This might seem obvious, but if there are accidentally 2 correct answers, then that's not a good question. Make the distractors appealing and plausible. If the distractors are obviously wrong, students will easily locate the correct answer, even if they have little knowledge. Use numbers and items from the dataset, visualizations, and text as good candidates for distractors. Make the choices grammatically consistent with the stem. Keep the distractors similar in length and type of language. And place the choices in some meaningful order, if possible, such as numerical order, chronological order, or some sort of conceptual order. By the way, if you want to learn more about the carbon footprint of meat, check out this visualization by Our World in Data, and it will be linked in the description. So once you have a multiple choice question, here's what putting together the assessment could look like. Let's say you have 2 designs that you are considering and haven't decided which one you want to go with. You could recruit 20 or so people to help you out. Give 10 of them the first graph in your question, and give the other 10 the other graph in your question. Then you compare how many people got it right for each design. Some other things you could do here is if you expect some people to have prior knowledge about the topic, you can do a pre-test and a post-test. First, the pre-test, you would give them just the question without the graph, and see how well they would do with just guessing or by prior knowledge. Then you would, in the post-test, give them both the graph and the question to see how much the accuracy changes. Another thing you could do is to show people the graph, allow them 60 seconds or so to study it, and then take it away and then ask your question. This will really test whether they remember the information, not just being able to read it off of the graph, but to be able to recall it after it's taken away. Another option is to just ask an open-ended question such as, what is the main takeaway this graph is communicating? There may be some downsides to this as it's more generic, so it might not actually capture your specific learning objectives. Also, an open-ended question will be harder to grade or evaluate whether they've really achieved the goal. So you might need to develop a rubric with what the correct answers are. But some higher level learning objectives may be harder to assess with multiple choice questions, so an open-ended question might work here. If creating a multiple choice question seems too daunting for you, you could start out with an open-ended question, if that sounds like an easier option for getting started with evaluations. Okay, now for a short pop quiz. This graph shows the number of World Heritage Sites in 3 countries in 2004 and 2022. Let's consider a learning objective of, the viewer will recall that Sweden used to have over half of all sites and now has under half. Out of these 3 options, what would be the best multiple choice question to test this? A, true or false? Sweden used to have over half of all sites and now has under half. B, what percentage of sites did Sweden have in 2004 and 2022? And C, which country gained the most new sites between 2004 and 2022? You can pause the video now if you need a few more seconds. Okay, so to talk about each of these options. This first one is definitely on the right topic, but true-false questions are easier to guess because there are only 2 options. So this is not a bad question, but I think we could do a little bit better. I would choose this second question as the best one because it evaluates the knowledge of Sweden's share of the sites. This third one asks about the metrics of the number of sites, but it doesn't actually assess this specific goal. Okay, so to recap, learning objectives are useful for describing goals, which can be helpful for when you are collaborating with other people. Learning objectives can also help you design better visualization or choose amongst several designs. And one of the things that can help you choose amongst the designs is evaluation. These multiple choice question assessments can be used to evaluate the designs to see if your goal has been achieved. My name's Elsie, and this video was brought to you by me and my collaborator, Eitan Adar. Some of this material was based on a resource from the Center for Teaching Excellence from the University of Waterloo, and I will link that in the description. Check out the next video in this series, where we put all of these concepts together into actually creating a data visualization.